Okay, hello everyone, welcome to today's video where my partner Frida Loa and I, Fernanda Garcia, are going to teach you how to optimize an investment portfolio using a linear method, which is the conditional value at risk. We are also using Excel and Solver. So let's start by providing a little introduction to the main problem we are willing to solve here. So basically, we are recognizing that there is a trade-off relationship between risk and return. Whenever we have high risk, we can also expect potential returns that are higher. But whenever we have a low risk, we also expect lower returns. So as investors, we are willing to have higher returns with a lower level of risk. By recognizing this problem, we are willing to optimize our portfolio to maximize our returns while also minimizing the risk. So now let's establish some basic concepts that are going to provide us with the understanding we need to solve this problem. First, we have the concept of an investment portfolio. It is basically a collection of financial assets like stock, bonds, commodities, cash, or cash equivalents. The main reason to build an investment portfolio is also to manage risk. By diversifying our total investment, we can protect us against the volatility of the market. Here we have an example with the total amount of the investment is divided into different percentages. We can see, for example, that we have international stock with a 12% and domestic stock with a 35%. We have also other type of assets like the money market or bonds.
So now we have to know what is optimization. So the portfolio optimization is the process of constructing an investment that maximize returns, but at the same time minimize the risk and the achieve a diversification. In this graph, we have two lines. The first line that is like linear line is the portfolio optimization is the portfolio, and the other ones, what is like curve line, it's the diversification of the portfolios. So it is know that when these two lines touch each other, we have this called optimization. So that is what we intend to aim in these scenarios that we are going to propose for you. As well, we have to know what is the conditional value at risk method. So this is an assessment. This risk is assessment measure that quantifies the amount of tail risk in an investment portfolio. The CVR is derived by taking a weighted average of extreme losses in tail of distribution of possible returns beyond the value at risk. Is used in the portfolio optimization for effective risk management. So this is like we aim to have like lower risk but high to maximize the returns. Now the formula. So we are using the formula of Rockefeller and USF. And the A is a confidence level, the pi is the probability weight assigned to a scenario, the R represents the returns of asset in a scenario, the X the portfolio weights, and the V is a variable representing a statement of the value risk bar. So now we're going to present you the scenarios, the portfolio optimization using Excel and Solver to understand better the method of CVR. So the scenario one is, in this case, we assume a risk adverse scenario, considering that 20% is the maximum risk. So we are willing to diversify our investment by investing in all of the 7 franchises. We also assume that there is a limit of budget of $2,000. The thing is that we chose these franchises just as having in common that there are fast food franchises, but they're not like in the same fast food industry, but taking into consideration that we don't choose like for a specific reason. It's much more like we wanted to know. So let's start with the first step. So now we are also as well opening Excel so you to know how to solve this problem. As a first step, we need to add our historical quotes. We use McDonald's, Wendy's, Krispy Kreme, Starbucks, Papa John's, Texas Roadhouse, and Domino's Pizza. And of course, we download all the data set in order to have a better version of them. As you know, it has dates.
So we are working with a complete gear of closed values for all the different stocks.
The next step is to calculate the returns. We are going to do at the same time.
So here to calculate the returns, we are using this formula in which we are taking the current value and we are subtracting the previous value from it, and then we divide the result over the previous value. This helps us to know which is the change in the value of the stock.
As well, we put the numbers, so we know all the possible decimals. And we run the formula for all the columns. Then we have to do the same formula for all the franchises. Now we have the returns column complete for each franchise. Let's go to the other step.
So now that we already have the returns, we are going to calculate the expected returns. For this, we are going to use the average formula, and we are going to calculate the average of all the returns that we observed during the period for each asset, and that's going to give us the expected return.
And we do the same for each franchises. So now we just like run the formula. Then we have to create a cell in order to know the distribute of the weights. In this case, we make this one. And we need to make sure to have a constraint in mind that the total of the weights must give us 1. So let's go to the other step.
So now that we have that ready, we are going to calculate the return contribution of each asset. For this, we are going to use this simple formula that is multiplying the weight of this stock in our portfolio by the observed returns that we have.
We must know that the weight must be fixed in order so the value doesn't change. Since we don't have the weights yet, all is going to give us 0, but we are just putting the formula in order to know. Then we do the same for Wendy's, fixing the weight, and it's the same process for each franchise. So next we are going for the next step.
So at this point is where we start applying the Rockefeller and Urjaret formula. And first of all, we are going to calculate the R sub index IX, which basically means that we are going to do the sum of the return contribution of each asset for the same period. So for example, we're using the sum formula and we are summing all the return contributions for all the different 7 franchises on the same period. And we are doing that for all the periods that we have. Then on the next step, we are going to calculate BR. And for this, we need to set an alpha, and we also need to know our total number of scenarios. In this case, we are establishing a 5% alpha to keep a traditional approach with a 95% confidence level. And we also know that we have 248 scenarios. Next step is to calculate the add position. For this, we are going to use the round formula, and we are going to use our alpha and our total scenarios. Once we have the add position, we go to the next part of calculating the PR, in which we are going to use the small formula, and we are also going to use the add position that we already calculated, and the values that we calculate for our subindex IX. Now we can go to the next step of applying the formula, which is calculating U. For this, we are using the maximizing formula, and we are going to maximize the BR times the R subindex IX.
Since the bar is not changing, we must fix it in order that the number doesn't move or change. Repeat the process for all the columns.
Here we can also note that whenever the risk observed is higher than the BR, it is going to be positive, and it is going to be contributed to the risk that we are calculating on the formula, the conditional boundary risk. And whenever it is lower, it is going to be equal to 0, so it is not going to be included into the calculation. So this is illustrating how the conditional value at risk method functions, focusing on the tail risk for extreme cases. So once we have that calculated, we are going to calculate the probability weights of all the different scenarios. In this case, we have 248 scenarios. So we divide 1, which represents the total weight, times over the total amount of scenarios we have. And we do that for all the scenarios, which have all the same weight. Finally, we can start calculating our CVR. For this, the first step is to multiply our probability weight for every scenario by our U, which is the maximization of all the risks that exceed our BR value. We do that for all these scenarios, and now we are going to sum all these calculations. Once we have that ready, we can calculate our CVR by dividing the sum of
By dividing the sum with the alpha, and the result we must um, uh, rest in the bar position. So that is how we are going to have the CVR. Then we calculate the portfolio return. That is the sum product the return previously calculated. And we take the K27. And that's how we calculate the portfolio return. The next step. Then if you want to explain the next step.
Oh, yes, thanks. So the next step is to calculate the amount of dollars we are investing in every asset. And for this, we are basically multiplying the weight assigned to every asset times the total amount of the investment that we have available. In this case, we are considering a budget of $2,000.
As well, it is important to fix it in order that the value doesn't change. And we do the same for each franchise.
And finally, we are adding a cell to set our maximum level of risk desired, that in this case is 0.2. Finally, when we have all this set, we are able to just run the solver and obtain the results. So the first step is to open solver, and then we are going to choose, for this scenario, the CBR as the value to minimize. Then we are going to choose the different weights of the assets as the variables that we can change. And finally, we are our constraints. First, we need to consider that the addition of all the different weights must be equal to 1. We also need to set that all our weights must be positive, that our CBR cannot exceed 0.2, and that our weights can exceed the 1%. Once we have that set, we just need to run the solver. And it is going to find the best option for us. Now we can go to the presentation to review the results and discuss. So here in the presentation, we can see that for this scenario, we are investing the major percentage on McDonald's, and also Domino's has a strong weight. We can also see that our CBR is 0.014, which is lower than the 20% that we set, so that objective is achieved. But we can also see that it is giving us a really small portfolio return. Um, Now we are going to review the other scenarios to see how these results change. So in this scenario two, we set a case where we are considering that the maximum CBR is also 20%, and we are willing to diversify our investment, but we want to invest at least 10% of our total budget in every franchise. And we are also considering a 2000 budget. So to solve this scenario, we are basically following the same steps that in the first scenario from 1 to 13. And then when we are going to run the solver, that's the only thing that is changing. And it's that in our constraints, we need to add a specification that says that the weight of every stock must be of at least 0.1 or 20%. So again, we run the solver and we can see our results. We can see that for this scenario, we are indeed investing at least 10% on every asset, but we are focusing the major weight of the portfolio on Krispy Kreme, which makes sense because if we remember in the expected returns, it was the most profitable stock of the portfolio. We can also see that for this, we have a CBR value of 0.05%, which is also below the 0.20% that we mentioned previously. However, the risk is higher than in the previous scenario, but so do are the returns with a 0.004 of return. So in the third scenario, we want to maximize the portfolio returns. For this, we set a target return of 10%, and we are also considering a limited budget of $2,000. To solve this scenario, we again follow the same steps that in the scenario 1 from 1 to 13. And the only thing that is changing is that when we are running our solver, we are going to choose the portfolio returns as the objective cell, and we are willing to maximize it. Our variables are going to be, again, the different weights that we can assign to every asset. And on the constraints, we are going to add a constraint that is going to state that the portfolio return must be equal or more than the target return. So once we have this set, we run the solver and we are able to analyze the results. As we can see in our results, the entire investment is going to Krispy Kreme. This makes sense as Krispy Kreme is the most profitable out of the different stocks that we choose. However, we can see that we are not reaching our target return. We are only having a 0.2022% of returns against the 10% that we were willing. This is because from the stocks that we have in the data set, 4 of them are not profitable at all. Actually, the expected returns of them is a loss. And from the 3 that are profitable, they are not profitable enough to reach this target return. So that will be the problem here. But we can also see that we have a 7.5% of CBR, which is still below the 20% that we choose in the beginning. And finally, we have the scenario 4. In scenario 4, we are willing to maximize the portfolio return, but we are willing to diversify our investment at the same time. So we have 3 chosen franchises that are Wendy's, Krispy Kreme, and Papa John's. These are the more profitable stock from the dataset according to the expected returns. And we are willing to invest at least 20% of the total budget on every one of them. And we are considering a limited budget of $2,000. So to solve this scenario, again, we follow the same steps that in scenario 1 from 1 to 13. And then the only thing that is going to change is how we set our constraints in the solver. So when we open the solver, we are still choosing the portfolio return as the objective cell to maximize and the weights as of our variables. But now we are going to add the 3 chosen franchises, and we are going to specify that the investment in these 3 franchises must be at least 20%. So once we have that, we can run the solver and analyze our results. As we can see, in this case, we have a 20% on every one of these scenarios, of these stocks, but the major weight is set on Krispy Kreme, which again makes sense because it is the most profitable. We can see that our portfolio return is slightly lower than in the previous scenario with a 0.19% of returns. And we can also see that the CBR for this scenario is slightly higher as it is 5%. So what we can conclude from all this?
Well, in scenario 1, we have the balance allocation. So the worst 5% of cases is the losses greater than 1.3%, average extreme loss is 1.4%. The expected return was 0.004%. McDonald's and Domino's will have the highest weights despite the negative expected returns. And the scenario 2 is higher risk, higher return. So the worst 5% of cases, losses greater than 2%, average extreme loss is at 3.4%. The expected return, we consider the 0.1%, and Krispy Kreme has the highest weight due to its 0.22% expected return.
In scenario 3, we have a maximizing returns scenario where all the investment goes to Krispy Kreme, and we have an expected return of 0.22%. So in this scenario, the worst 5% of the cases, we are expecting losses greater than 3.8%, and the extreme losses will be 7.5% in average. For scenario 4, we have a diversified high return portfolio where we are investing in the top 3 franchises. We have an expected return of 0.19%, and in the 5 worst percent of the cases, we are expecting losses greater than 2.6% and an average extreme loss of 5%. In this scenario, Krispy Kreme is holding 60% of the budget, which is still a major percentage. So from all these different scenarios, we can observe the trade-off between risk and returns, which is one of the concepts we mentioned at the beginning. We can also take into the effectiveness of the CBR method to optimize portfolios, taking the level of risk as the main indicator of the portfolio performance.
And also that
But still, the best option is going to depend on which type of investor we are talking about. For those that have a more averse frame against risk, it will be better to choose a portfolio even if it is not as profitable, but still with a low risk. And for those that are less averse to risk, they can choose a portfolio like in scenario 4. However, it's important to note how these statistical methods help us to take optimized decisions while investing that are based on mathematical results and analysis of the stocks.
And just to end, we saw that choosing these franchises was not that the best option to invest, but let us know that it is important to have in consideration which franchises are like in a better positions to know how to maximize our returns. And thank you for your attention and that be it.